Hey there, Mustangs. Welcome back to another edition of No Here, No Problem. Rosenwald here talking about the law of cosines today. Fairly easy subject. It's really just something where we're just going to be plugging in some numbers and using our calculators to solve for some missing values. Kind of treat it like the Pythagorean theorem, but just realize that there's a couple things that we have to do, which is using inverse trig to solve some of the problems. And there's certain limitations on what we can actually do with this, okay? But real easy. Let's go ahead and jump right in, okay? So, if you remember last time, we talked about using the law of sines when you're given a problem where you've got angle, side, angle, 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 side, or angle, side, side. Well, with the law of cosines, this is very specific. You could only use the law of cosines when you're given side, 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 or side, angle, side. So, if you are given two sides in an angle, not in the order of angle, side, side, but in side, angle, side form, and if you're given all three sides, then we use the law of cosines to work through and solve this. So how do we use it? Well, when we look at these formulas here, you'll see that there's a lot of repetition between them in terms of like the formation, right? We have our a squared right here, and then we have the angle that corresponds with it over here. We have our b is our side over here, and we have the angle that corresponds with it over here. We have our c here, and then we have the angle that corresponds with it over here. So one of the things I'm going to tell you is, as you're working through these, is don't always get hung up on the letters so much as instead of focus on maybe more the positions. Okay. So for example, like if I gave you a triangle and I say that this is a given angle right here, well, the side over here is given to us. That could be any one of these situations then. It could be this and then the angle that's given. So you'll see what I mean later when I don't necessarily have letters given to me, but instead I have a missing side given to me and then the angle that corresponds with it. So I would have like a missing side given to me and then the angle that corresponds with it. Or I can have the missing side and the angle that corresponds with it. Okay, you'll catch on pretty easily. So there's an alternative method that we can use. When we're given side, angle, side, we have to use these formulas. But if by chance I'm given, let me make myself smaller here because I'm in the way as usual. Um, if I'm given if I'm given side, 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 okay, I can use the formula that's over here. I'm just going to have to work through and kind of solve it a little bit. But the process would still get me back to this exact form right here. So you don't have to memorize the different formulas. This will ultimately lead to this. It's just that this one on the right side here with the side, 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 this is our shortcut. So if you were to think about like trying to get cosine of a by itself, if I said that this was equal to a squared, get rid of this right here, I would have to move the b squared over, so I'd have minus b squared. I would have to move the c squared over, so I'd have minus c squared. And then I would have to divide by negative 2bc. All the negatives and everything would cancel each other out, and we would end up with this formula that's right here anyways. Okay. In order to get your angle by itself, just remember that you have to use inverse cosine to clear out the cosine and make sure that you're in degrees. So ultimately the answer on this would be like inverse cosine of this entire thing over here. Okay, that would be just thrown into that. Okay. When you're using the alternative method for side, side, side here, it's important you have to use, or you have to find the biggest angle first. Okay, it's just a prerequisite. What happens is you actually end up with some fake values if you do other ones first. That's usually because of ambiguity as a result of the law of sines, which these two kind of go hand in hand. You'll see how you can actually use them here in a minute. Okay, so let's just jump in. It's the easiest thing to do. Let's just jump in. So for side, side, side case, you're given right away all three sides. Immediately you should be thinking, oh, side, side, side. I'm going to go ahead and use this form right here. Well, if that's the case, then remember we have to be using the largest angle first. So that means we're going to look at this right here. We're going to be finding angle C first. Well, now look at the formula here. Which one helps me to find angle C? That's this guy right here, okay? So in order to find angle C as my first angle, we're going to go ahead and set up the law of cosines here, which means when I set this up, we're going to have 21 squared. That's the c squared. So this will be c squared is equal to a squared plus b squared minus 2ab cosine of c. And just plug in the values. We're going to have 15 squared. We're going to have 7 squared minus 2 times 15 times 7. And then we're going to have the cosine of c. Okay. That's setting it up in the regular form. Now, if I was to go through and try to solve it using this form, the setup would be the same, just using the same values, but just in the different equation. So it would be cosine of c is equal to a squared, which is 15 squared, plus b squared, which is 7 squared, minus c squared, which is 21 squared, over 2 times 15 times 7. Throw all this into your calculator, you're going to get a decimal, and then we're going to say cosine of inverse, I'm sorry, c is the inverse cosine of whatever that decimal is. Okay? So the answer for that when you plug it into your calculator is going to be 142.68. Okay? Once you know one of your angles, now you have options. Now, because you have other information given you, you have angle side side, you have angle side angle, you have side angle side, like you've got all this information now. You can go ahead and start using law of sines, or you can keep going with the law of cosines. I personally don't like switching back and forth between them. So what I generally do is I'll just stick with one. So measure of angle A, just using the formula from up above here, throw in the values, you're going to get that we have 25.66. Doing the same thing for angle B, just throw the values into the formula and you end up getting 11.66. Okay? All right, let's move on to another situation. Again, this is side angle side, which means I don't have the ability to use the alternative form just yet. I have to use the side angle side forms, which is this. Okay? So let's just set it up. I have letters given to me. So when I look at this, I'm sorry, I didn't actually have letters given to me. When you look at what's given here, there's no letters, right? And so this is what I was saying. Don't get hung up on the letters. Get hung up on the fact of what's given to you and what's missing, right? I'm given an angle right here. Across from it is the diagonal that we're trying to find. So that's x. So we have a side given to us, and then we have an angle that's given to us across from it, okay? That means I can use any one of my formulas. So if we set this up, we're going to have x squared, because that's the missing side, is equal to a squared. Now, it doesn't matter which one is my a and which one's my b. If I put in my a squared, we'll just say 15 squared plus 10 squared minus 2 times 15 times 10, and then the cosine of 115. Okay? What's important is that you recognize that these pair up, right? The angle and the side opposite it. These two don't matter the order because, 225 plus 100 is the same as 100 plus 225, okay? Just like here, it doesn't matter which order I have because if I have 10 times 15, that's the same as 15 times 10. So the order didn't matter. So what matters again is that you pay attention to the side and the angles that are opposite each other when you're setting up the formula, okay? So we have this for the formula. We have c squared is equal to, you just throw in that whole right side, don't try to do bits and pieces, and then take the square root of all of it, you get 21.26. Now that we know the length of the diagonal, we can find all of the other parts that we're missing. The angles, we can use the law of sines, we can use the law of cosines, totally up to you. I went ahead and used the law of sines in this case, just to experiment with it. I got 39.76 for my b. And then now that I know two of my angles given to me in my triangle, I've got 115 and I've got 39.76. That's the beta that's right here, okay? I know that in a triangle, there's 180 degrees. So I do 180 minus those and I get my last one, which is 25.24, okay? In engineering, let's say I wanted to try to measure something that I can't traditionally measure, okay? So I can't just go right across the river or the lake measuring this. So how do we measure it? Well, we use triangulation to do this in the real world. And so what we could do is, in this case, we have a guy that's, he's a surveyor. He walks across 200 feet from one corner of a pond out in the distance. So he walks 200 feet. He then takes himself and he turns 80 degrees. He can calculate that. And then he continues walking 160 feet back to the other side of the lake. So from here, you can see we have a side angle side situation going on. And what they're asking us for is, well, what's the approximate length of the pond? So they're asking us for x right here. So again, they're asking us for x. We've got the angle and we got the side opposite it. Just set it up like traditionally, like we just did in the last ones. Don't worry about the letters. Worry about the setup here, okay? That when we set this up, the unknown side right here is across from my angle. So the unknown side is across from my angle. okay? And then the 200 and the 160 are interchangeable. So it's 200 squared plus 160 squared minus 2 times 200 times 160, cosine of 80. Throw this whole right side into your calculator. Take the square root of both sides. And we get 233.42 feet is how wide this lake is right here. Okay. Let's look at another example here. So in this case, Mookie Betts is a player. He's a center fielder for the Yankees. He's approximately 300 feet from the television camera. So now try to think about what the scenario looks like, right? We've got a baseball field. I'm going to go ahead and draw the baseball field. Okay. He's 300 feet. I should probably finish reading it. He's approximately 300 feet from the television camera. So we got the baseball field like this. He's somewhere over in the distance here, and the camera is somewhere right here. And it says from behind home plate. Okay, so that's where the camera is, somewhere behind home plate. Jacoby Ellsbury hits the fly ball that goes to the green monster 350 feet away from the camera. So the guy hits a ball, boom, it goes off in the distance, 350 feet. The camera, which is normally facing the player now, has to turn to actually follow the ball. So now the camera is going off in this direction, following the ball, but the runner has to run towards the ball. Okay, the outfielder has to run towards the ball. So the question is asking, how far does the runner have to run? So this is what the scenario looks like. Okay, the camera has to turn 8 degrees to follow the play. The player's 300 feet out away from the camera. The ball goes 350 feet. Okay, travels out 350 feet towards the wall that's off in the distance there. Okay, so the wall is going to be over here. The player, who's right here, has to run and chase down the ball. So he has to go this direction to get to it. The question is, how far does he have to run? So let's set this up. Ready? It's a side angle side situation. So we're going to have to use the law of cosines, obviously. Okay. When we look at the unknown side is across from an angle. So again, just match these up. So when we set this up, you're going to have your unknown side. Let me zoom in here. You're going to have your unknown side matched up with the angle that's given to you. And then everything else just kind of falls in between. 350 squared, 300 squared, minus 2 times 350 times 300. Put this all in, multiply it out, take the square root, you get 67.41 feet. That's how far he had to run. Okay. All right, let's move on to Heron's formula. So last time we talked about, in law of sines, you were able to use a formula, which is area is equal to 1/2 AB cosine of C. I'm sorry, not cosine. Area is equal to 1/2 A times B sine of C. Okay. And then there were 3 different forms that were interchangeable for this. You had 1/2 BC sine A. You had 1/2 AC sine B. So there were 3 different formulas that we can use for this. Okay. That was when we had the law of sines taking place, where you had angle, side, angle, 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 side, angle, side, side. Or if we had side, angle, side given, we can use that as well. Well, Heron's formula is a really cool specialized formula. This formula works when we have all 3 sides of a triangle given to us. Okay. Now think about what you would normally have to do. If I had all 3 sides of a triangle given to me and I said, what's the area of a triangle? The normal area is half the base times the height. So this right here would be my base and this right here would be the height. Now think about all that would go into this. If I gave you a side, let's call this a 5, this is a 12, and this is a 13. Okay. Well, if I want to find the area of this, I would have to take this and find the height. Well, in order to do that, I would have to then go ahead and figure out what the angle is right here. And then from there, I could figure out what the height is from there. And then I could do half the base times the height, right? Whole process. With this, I don't have to do that. Instead, we use the formula, which says we take the square root of s times s minus a times s minus b times s minus c. Sounds like a lot, but it really isn't. S stands for the semi-perimeter. That is half the perimeter, which is half of the distance around your triangle. So that means you take all 3 sides of your triangle and add them together and divide it by 2, and this is now the S value that we're going to use in the problem. You then take the S and you put that obviously in each one of these parts, and all you're going to do is subtract the original number that was given to you. Okay, so let's do this in action. Let's see what happens. So we have a triangle with sides 75.4, 52, and 52. To find the S, the semi-perimeter, add all of them together, and cut it in half. So I get half of the perimeter. So this is adding all of them together and dividing it by 2. That is now 89.7. So half of the perimeter is 89.7. So now we're going to take this 89.7, we're going to put it in for each one of these S's in my formula. Okay? And then what we're going to do is we're going to subtract that A value, that B value, and that C value from that S. So what does that look like? We have the square root of 89.7, that's my S value. Then we have S minus A, then we have S minus B, and then we have S minus C. Okay? And you just take the square root of the whole thing, and believe it or not, that is your area. Now, how do I know that this is true? Well, let's do one more, and then I'm going to prove it to you, okay? So let's find the area of this triangle. It's a 3, 4, 5 triangle. Add all the sides together, okay? And if we add all the sides together, we have 3 plus 4 plus 5 divided by 2, which is equal to 6, okay? Throw it into your formula. You're going to have the square root of 6 times 6 minus 3 times 6 minus 4 times 6 minus 5. That's your S times your S minus A times your S minus B times your S minus C. Okay? Go ahead and simplify this. We get the square root of 36, which is equal to 6. Well, if you didn't recognize it right away, 3, 4, 5 is actually a right triangle. And so if I was to draw this right triangle, remember the formula for the area of a triangle is just half base times height, right? And so because this is 3, 4, 5, I know that the base and the height are just 3 and 4. So 3 times 4 divided by 2 is 6. And you could see these work out to be exactly the same thing. Now, which one's easier? It actually doesn't matter. It's exactly the same. I personally would have done this if I know that it's a right triangle. But if it's not a right triangle, you have to use this, or you have to find out more information before you can do anything. So the question is, which area formula do we use? Because now at this point we've learned a couple. Well, if you're given side, 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 just use Heron's formula. It's the easiest, it's the fastest, it's no problem. If you're given side, angle, side, use your sine formula. That's at half BC sine A, or half AC sine B, or half AB sine C, okay? And if you're given a right triangle, just use half base times height. If I have a different situation, let's say it was like angle, angle, side, angle, side, angle, angle, side, side. In order to find the area of this, unfortunately, I would have to find more information first, and then I can use one of these formulas after that. But you have to use the law of sines or the law of cosines to find the missing stuff so that we can then plug this in, okay? Actually, it would be the law of sines you would use, because if you had the law of cosines, you would have sine, side, side, which you can use this, or side, angle, side. Okay, but that's pretty much it right there. Let's try one last problem here. Okay, you have a parking lot that has the shape of a parallelogram. The lengths of the two adjacent sides are 70 meters and 100 meters. So obviously I put the longer one at the top and then down here. Okay, the angle between the two sides is 70 degrees. So what's the area of the park? Well, think about what I'm given. Side, angle, side. If I use side, angle, side, look at our formulas up here. Using side, angle, side, I would go ahead and use a sine formula. So again, don't get hung up on the letters. There's no A, B, and C in this, right? It just means take and multiply the two sides that are there, and then multiply by the sine of the angle that's provided. And so what that's going to do is that's going to give me the area of just this one triangle. But since it's a parallelogram, I've got two of these triangles. And so look what happens. I have half sine of 70 half of 70 times 100 times 70, sine of 70. But I've got two of these. And so what happens is that half and the two ultimately negate each other, and this is what I'm left with. Okay? Now, let's talk about something, okay? The area of a parallelogram, if you actually look at the definition, area of a parallelogram is just their base times the height, right? Well, I've got a base. My base is given me. It's 100. But what about the height? I don't have a height. What could I draw in a height? Well, if I wanted to draw in a height, I can actually draw in a height right here, couldn't I? And if I drew in the height that's right there, I'm going to redo that, all right? If I drew in a height right here, like this, hopefully you can see that this actually generates a right triangle for me here. Once I have a right triangle, I can use SOHCAHTOA to find the height of this triangle. And so if I look at it, I can figure out, well, I'm given the opposite and I'm given the hypotenuse. So with the opposite and hypotenuse, I will use sine. So we could set that up and say the sine of 70 is equal to the height over 70. And that means that my h is going to be equal to 70 times the sine of 70 degrees. And if I put that down here for my h, I put in 70 times the sine of 70 degrees. Now look at what happens, okay? Right there, you should see that is the same as this formula right here. But the formula for the area of a parallelogram is both of the triangles already combined versus this, which says take one of the triangles and double it. And this half and that 2 would cancel each other out, leaving you with the exact same formula as what we have. Okay? So that's where that formula actually comes from. So that is it, my friends. Hopefully that made sense. I know I went a little quick through it, but it's real quick. Just make sure of anything, not just that you understand it, but you put all the stuff in the calculator and you understand how to do the computations, okay? Otherwise, get started on the practice. You guys take care. Be safe. Be responsible. Don't forget to like and subscribe, and you have a wonderful day.